Hi children, welcome back to our class. Last few classes we have seen the classification of matter and now few classes we will see the different separation techniques adopted to separate the components of a mixture. Okay, one by one we can see the different methods of separation adopted for separating the components of a mixture. First method for us is evaporation. Normally we know evaporation is taken for separating the liquid and solid components of a mixture separately. If we want to collect that solid component present in a solution, in a mixture, liquid mixture, then we will adopt the method of evaporation there. For that we can take one example which is given in your textbook, that is colored components of a dye. Suppose that different colored components will be there in that ink. Okay, ink, normally pen ink we have to take. So ink is a dye which is a coloring pigment, and that ink is a mixture of colored pigments in water. Okay, colored pigments when dissolved in water we will get the ink. So how will you separate that solid colored component and that liquid water there? For that we have to adopt the method of evaporation. First we have to take that mixture to be separated, that mixture in a watch glass. Okay, 2-3 drops of ink we are taking in a watch glass, and we are not directly heating it to get that solid component separately there, because it is an organic dye. Okay, ink is an organic dye. On direct heating that will decompose. There is a chance to decompose. So to avoid the decomposition we will not directly heat it. We will indirectly heat it. For that we have to take a beaker there. Take some water in that beaker and place that beaker on the burner using a tripod stand. Okay, using a tripod stand you place that beaker on the burner there, and above that beaker you just keep that watch glass in which our mixture is taken. Okay, our mixture is ink. Okay, so that watch glass we are just keeping on the top of the beaker. So we can see that detail, that apparatus is shown in your textbook page number 19, figure 2.5. Page number 19, figure 2.5. Okay, now we are taking that beaker there, and in that beaker, above that beaker we are keeping the watch glass. Okay, in this above this beaker we are taking this watch glass there. Okay, and in this watch glass we are keeping the mixture to be separated. Suppose here we are putting the mixture of ink. Okay, ink mixture. Then we are keeping the tripod stand there. Like this, three legs are there, that is why we are telling this as tripod stand. And we can keep this here. Like this, and we can show the burner there, and we have given that heat energy there. We have started burning that burner, and using that energy, that water kept in this beaker will get evaporated first. Okay, with that water is taken in this beaker, and water with that heat energy is this mixture which is taken in that watch glass, that water content in that watch glass will get evaporated, leaving a solid material there, which will be the colored dye. Okay. So, on heating, what you have to observe there? We can observe here vapors are going, the vapors of water will be going up by absorbing the heat energy, and this is the ink mixture, this is the watch glass, this is the watch glass, and this is the beaker there. Okay. So, a solid component mixed with a liquid component will be separate. From that mixture, the solid component will be separated by adopting a method of evaporation. If it is if we are heating that mixture, directly heating, if it undergoes decomposition, we cannot adopt this method. So, such a mixture we are indirectly heating by keeping on the top of water beaker, so that heat energy from this water will be absorbed for the water content in that watch glass to vaporize. So, leaving the solid material there. Okay. So, this is the first method, evaporation, and we find that ink is a mixture of dye in water. So, we can apply this separation of this solid component of ink by using the method of evaporation. And this method is applicable if the component present, liquid component present is volatile and a solid component present is a non-volatile. So, we can say that a non-volatile component can be separated from a volatile liquid component. So, that is the thing, non-volatile. What do you mean by volatile? Last chapter, first chapter we have seen that. What do you mean by volatile? Easily evaporating liquids, liquids which has low boiling point, easily evaporating liquids, we are calling them as volatile. Alcohols, isn't it? Alcohol, acetone, all these are easily evaporating. So, a non-volatile, that is solute. A non-volatile solute can be separated from a non-volatile solute can be separated from a volatile solvent. Separated from a volatile solvent. A non-volatile solute can be separated from a volatile solvent, that by the method of evaporation. So, evaporation is a method to separate a non-volatile solid component from a volatile liquid component. Volatile means like water also. Water does not have a low boiling point, but it can easily vaporize. Okay, by absorbing heat energy, it can be easily vaporized. So, we can say that this is the technique of evaporation. I think this is clear. Okay, then we can see to next method, that is centrifugation. Second method is centrifugation. Do you remember that where we mentioned that separation method? Do you remember? Yes, correct. It is the separation technique for colloids. We have seen that. Okay. So, if you are getting a colloidal mixture, there we can use this method of centrifugation. There, that different components of a mixture are separated by difference in the densities. If different components, solid and liquid, or solid and liquid, or solid components are there, if they have different densities, definitely, mainly we are taking the liquid mixture there. So, if they differ in the densities, we can adopt the method of centrifugation there. Okay. Example, we can take milk, cream from milk. Okay, fresh cream we are taking, isn't it? butter, ghee, everything we are separating from milk. So many useful components are present there in milk. So different components we can separate by the centrifugation. So at that time what is happening there? We are rotating that mixture taken in a test tube or a whichever apparatus if it is, we will rotate it at the high speed. Okay, during that rotation and that materials will have different densities. So during that rotation time, higher material which have higher density will be going down and material which has lesser density will be coming up. So when we are rotating the milk, for during that centrifugation time, the cream will come at the top of the milk. So component with the lower density will be coming at the top and higher density will be going down if they have different densities, if it is rotated at high speed. That method is known as centrifugation. And example, we are separating cream from milk. Okay, cream from milk is separated by this method. During this, what is happening? Rotating in high speed. It is rotating in high speed. The components of a mixture is rotating in high speed. That time what is happening? Depending upon the densities, depending on densities, layers are separated there. Depending on the density, layers are separated there. So we can say layers are separated. Okay, during that rotation time, higher component with the higher density, component with the high density will be coming down, will be forced to down. Okay, component with the lesser density will be coming top. So here in the mixture of cream and milk, cream will be forced to the top and milk will be coming down. So this is the method of separation, and the principle behind is method of centrifugation. The principle behind is, depending upon the densities we are separating the components. A component with higher density will be forced to the bottom and with the lower density will be coming to the top when it is rotated with very high speed. Okay, clear? That is the principle behind it. Now we can see what are the different situations where we can apply this centrifugation technique. We are using this in diagnostics, laboratories and all. We are using this to test the different components of blood and urine. Different components, solid liquid components are there in blood. There are also RBC, WBC, like so different components are there in blood. Urine also different, uric acid, so many other things are present. So all these components in the laboratory separated by using the method of centrifugation. Then in home and all, it is used there in washing machine. Where we are using in washing machine, during what process we are using this method? Yes, it is to dry clothes. During in that dryer, we are putting that wet clothes there. So when it is rotated, water molecules will be going away from the cloth, so that cloth will get dry. Okay. And in dairies also, to separate butter and ghee from cream from milk, we are separating by this process, centrifugation, butter and cream. Okay. So these are the two separation techniques. Now today we have seen the evaporation and centrifugation. Evaporation from a non-volatile solute and a volatile solid liquid component as solvent is there, then such a mixture we are taking for evaporation. And if that components are have different densities there and that also will be separated by centrifugation methods. Okay, hope this much is clear to you. Thank you.